Hello, in this video we're going to talk about code comments, code spacing, different types of brackets, and different data types. Next video we'll talk about loops. To start, we'll open up the processing application, run it, give it a second to load. Okay, so here we are. Let's type the basic program. Void setup, then void draw. So let's talk about code comments. So code comments are a way for programmers to tell other programmers. It allows programmers to explain their code inside their code. And comments are created using the double slash symbol, the double forward slash symbol. And to create a comment, you type in double slash and then you can write anything after the double slash. As far as the computer is concerned, this program runs as if only these lines of code exist, so it ignores anything after the double slash symbol and the double slash symbol itself. So to the computer, this comment here gets ignored. So as far as the computer is concerned, only the void draw and the void setup are the only things in this program. You'll see me use the comments very often in code because it's useful to explain your code using comments. Let's talk about code spacing now. So code spacing is kind of tricky when you're learning how to write programs. When you write a declaration, for instance, so when you create a variable x and it's an integer, you can write this means the same thing as int x equals 5. So in line 2 you don't see the space between the x and the equal sign and the 5, but they mean the same. This error right here, you get this error because there are two declarations of the variable x, and in any program you can only declare a variable once. So here you're saying, okay, the x, I want to create the variable x twice, and you can't do that. You can give it a new value, and this is what this line of code does, but you can't declare it once. The computer already knows that x is an integer. There's no need for, there's no need to say, okay, I want to use the integer x again here. So int x is the same as, so instead of int x, I'm going to use int y now. So you can declare variables without the spaces here. So the space is to the left or to the right of the equal sign. But what you can't do is have no spaces between int and a variable called z. This doesn't make any sense to the computer. Int here is a keyword, that's why it's highlighted. These are all keywords, which are the reason why it's a different color. So when you write it this way, the int part of this declaration doesn't get highlighted because you've combined the z and the int, and now the computer is going to be confused. It doesn't know what to do with this line of code because it's actually not the right lines of code. It's like misspelling. If you're trying to spell please, but instead of writing please, you write place. This is wrong. It doesn't mean please. In computer programming, if you write int z equals 6, this is wrong. It's not the same thing as int z equals 6. Even though int z equals 6, like this, means the same. What's weird about spacing is that where the computer allows spaces, it allows a certain number of spaces. So this will mean the same thing as this, which means the same thing as this. computer won't differentiate between um, line 4, 5, and 6. Now, if I delete this, this program will run just fine as far as the computer is concerned. This is the same thing as int z equals 6. This is another way to sort of write a declaration, is to to put a huge amount of spaces in between the int and the q. This is okay as well. It's more difficult to read than line 1, which is why we don't ever see, declarations written this way. But it works. It compiles. The computer ignores the spaces here. It's just when you combine things that's where you run into problems. Okay, so typically I'll write lines of code, lines of declarations like this, with spaces between the equal sign, because it's just easier to read. This seems a little bit cluttered to me, but all comes down to personal preference. Another thing I like to note about code spacing is the spaces between different instructions. So instructions are separated by the semicolons here. To prove my point, you can have two instructions on the same line. So say we make two variables, call it variable 1, and let's set it. I know it's a little bit difficult to see, but this is actually a number 1. This is a number 1, this is a letter L. They look a little bit different here, but I can see how some people might find them similar. Let's make the variable 1, and let's set that to 100. And in our code, let's print out the variable 1. Okay. Let's delete that so that, let's run. Save and run, and then this print statement prints out the number 100. Line 1 is an instruction too. Actually, see this space here between the semicolon and the number? That gets ignored too, so this also makes sense. This will run, but typically people put a semicolon right at the end of the instruction. But this is a line of code, but it doesn't actually print out anything. The computer does run this. When it runs it, it creates the variable. The instruction number on line number 1 is different from the instruction on line number 5, in that the instruction on line number 5 actually does something. It prints things out to the console. So even though we don't see anything happening in line 1, it actually happens in the background. The computer runs this line. It creates a variable called variable 1 and assigns the number 100 to it. So it puts the number 100 in the variable 1. Line number 5 prints out the variable number 1. But okay, the reason why I bring spacing up is because you can have multiple. The reason why the semicolon is so important is because you can it tells the computer when the statement, the instruction, is over. So these two instructions, and so the program will actually run. The program will actually run even though I have two instructions on the same line. This semicolon here separates this first instruction and this instruction here. So it's as if so line 1 is the same as lines 3 and 4. You'll see that in a second here. That's saying there's a duplicate because line 1 and line 3 and 4 are saying the same thing. But if I first comment out these two things and I run the program, save and run, you'll print out 100 and 200. This first 100 is the result of the line 9. The 200 here is the result of line 10. Now we can give it each its own line by using the print line function. Right, there you go. Line 100, 101. Yeah, so line 9 prints out the 100, line 10 prints out 200. Now, if I remove line 1, by commenting it out and I put in line 3 and 4, you'll see that you'll get the same output. Yeah, see, it's the same because there's no difference to the computer. As long as you have that semicolon, it doesn't matter if you write it this way, 3 or 4, or if you write it this way. It means you're essentially creating two different variables, and that's all it means to the computer. But usually we write it one after the other like this because it's easier to read. This looks a lot more cluttered, so that's why programmers almost never do this. I'll just keep that there for now. Set that to 200. Okay, I'll just close that. Another note about code spacing is that the computer ignores all spaces with empty lines. So to the computer, this program here is the same as this program here. Okay, and the spaces here are also ignored. So this program here runs the same as if the program were written this way. Yeah, and it's also worth noting that you can put brackets like this. The program doesn't care about whether or not this bracket is on a new line. This program means the same thing as this program here. But I write it this way because it's easier to see the brackets and the different levels. You'll see why it's important to keep these brackets on its own line later when we nest code, where you might have something like this, where you might have print line variable 3. This is a nested operation where this function is, or the code that's in between these two brackets are inside these two brackets here. But don't worry about that now. You'll understand it later. Okay, so we talked about how spacing there doesn't matter. In general, just keep it this way so that it's easy to read. Okay, next we'll talk about the different types of brackets. So there are a couple of different symbols that you need to know. Let's put it in comments. So first up is the brackets, or parentheses. This is called an open parentheses. This is called a closed parentheses. Open, close parentheses. These are square brackets. That's an open square bracket. That's a closed square bracket. Square brackets. These are called French curly brackets, or most people call them just curly brackets. Okay, these are called angle brackets. That's an open angle bracket. That's a closed angle bracket. Angle bracket. Angle brackets. And let's see. Yeah, those are all the brackets that you'll need to know. Let's go over slashes. So that's forward slash. And this is called a backslash. Let's see, what else? What are the symbols? So you know about the colon and the semicolon. I'm sorry, the semicolon and the colon. Let's see, this is a quotation mark. The first quotation mark, the quotation marks look the same, but the first quotation mark is called an open quotation mark. The second quotation mark is called a closed quotation mark. Quotation mark. If you just have one quotation mark, that's just called a quotation mark. So this is just, regular quotation mark. We just call this a quotation mark. See, this is called a single quotation mark. And you have single quotation mark, double quotation mark. This is also known as a double quotation mark. I'm sorry. This is also called a double quotation mark. Quotation mark. This is called, an open double quotation mark. This is called a closed double quotation mark. Let's see what else. I think that's all that you need to know for now. Yeah, these are the symbols that programmers often use. And so it's best that you practice them. Oh, I'm sorry. There's also a couple more. This is called a dash. The dash is next to the 0 key. And it looks like this when you have it next to a word. And this is called an underscore. So write a word next to it so you can see it side by side. It's a little bit difficult to see line 11 and 12 like this symbol and this symbol when it's written one on top of the other like that. But this is what it looks like when it's next to a letter. The dash it looks like it's in the middle of the character. The underscore is a score underneath the character. Yeah, but these symbols are all that you'll need to be familiar with when you're writing programming. When you're programming and writing code. And let's talk about data types in the next video. Then we'll talk about loops separately.